Well, we're here in Western Sydney at the site of Romar Engineering, this incredible mid-size engineering and advanced manufacturing company. Steve, tell us what you do here at Romar Engineering and tell us some of the applications and the opportunities that this technology can present for Australia to get into the kind of advanced manufacturing world.
Yeah, thanks, Jeffrey. So I'm Steve Milanowski, Head of Advanced Manufacturing. Romar Engineering is a leading contract manufacturer in Western Sydney. We predominantly work in the injection molding space for biomedical injection molding for silicon products. We're Australia's leading producer of the IVF consumables for silicons here in Australia, and it's a big export for us as well. The last 3 years has seen a bit of a change where we're adapting more advanced manufacturing methodologies. We've gone out and started a fluid and motion control business for mission critical applications, right? Valves, actuators, and the like. And that's very reliant on manufacturing technology. So, you know, CNC machining, 3D printing, inspection, metrology, all the rest. And then of course, you can't make something unless you have a design. So we've integrated that design component in the last 3 years, which has really been a labor of love for me.
So tell us about the difference that something like additive manufacturing, 3D printing does in the kind of way people think about manufacturing. Say for something like a valve, what's, you know, if I'm doing that for space or defense or just for sort of like heavy machining, what's the fundamental proposition it brings?
Yeah, so it's manyfold, but to hit the high points, number one is just when it comes to overall cost, and when I refer to cost, I mean total cost of ownership, right? So integrated assemblies. If we have many parts that become one, many parts that become some, there's actually a lot of cost reduction in overhead, in supply chain cost, and flexibility. When it comes to the fact that you're not removing material, you're adding material, you get a lot of mass savings, right? So in transportation, lightweighting is a huge thing, especially with electrification. So making structures that are lighter gets you more range, right? Which is always at a premium. And then of course, when it just comes to pace of innovation, right? Like, you know, valves have been around for centuries. A lot of the designs have really been nutted out at a very high degree of fidelity. What we're now finding with additive is it's opening up new doorways for us to kind of push these designs to chase the last few percent on performance, which is what our customers are really after.
And so, like, not being an engineer, but it just seemed to me that, you know, that capacity to produce one total part that wasn't the sum of many parts gave a lot more resilience and durability to some of the kind of parts of the manufacturing supply chain.
Yeah, exactly. And not only do we get that resilience in the sort of the supply chain management side, but in a lot of cases, the additive manufactured parts are also of higher integrity than, say, the traditionally manufactured parts. So the microscope, it's a very fast process melting and solidifying metal. What that means is that we get these really tight grains, which ends up not only increasing strength, but also ductility, which speaks to the durability standpoint.
Now, you talked about that sort of, you know, ingenuity, design and manufacturing coming together. We saw upstairs your designers, the person who then sort of starts to think about the manufacturing specs. Tell us how that works and why you think Australia has got that sort of leading edge in terms of ingenuity. I mean, why does, you know, how do we sell this story to the rest of the world?
I believe Sam from GE spoke to it the best, just saying Australia came from this remote outpost in its beginnings. So part of the culture is, if we don't do it, our survival may not work out the best, right? So there's this imperative to just solve problems that are in front of you in Australia. And I think what we find with our junior engineers that we bring in is there's this never-ending thirst for knowledge and always this kind of drive to solve these problems and be solutions-oriented with engineering.
And then your two guys are sitting there together, sort of like, that's not going to work, that's going to work. I mean, that's how innovation happens, really.
Yeah, and that goes back to the Kelly Johnson days at Skunk Works, where, you know, the machinist would be right next to the engineer. We do the same thing. So manufacturing sits next to design. What can I get away with That interface, typically there's a lot of friction, you could say a high drag coefficient.
Yep.
By placing them next to each other, letting them work through the real challenges and going for that, again, it's the total cost of ownership style problem where we're just looking at the most efficient way to solve the problem at large, not just in the design phase or just in the manufacturing phase. We have to look at it as a total life cycle, right? And that's where the value is at the interface.
Tell us about your people. How many people have you got working here? What are their backgrounds? You've got some PhDs, you've got John Engineering, graduate from Western Sydney University.
Yeah.
Tell us about the makeup of your people.
Yeah, so Romar's about 70 people right now. Predominantly, the large majority of that is those that are engaged in the molding activities. So polymer chemists, just molding technicians, tool and die designers, engineers, tool setters, quality. And then on my team, we have 13 engineers that focus on fluid and motion control design, advanced manufacturing, so the programming of the CNC machines, additive manufacturing machines. And our makeup is kind of across the board. So we have people that come with relatively little education. We have people that are at the upper end of the spectrum as well.
Yeah, because that's the story we've got to tell. This isn't all about the kind of super high school jobs. In something like this, you can have an array of jobs. It's great to see a lot of women working in the medical section. So cast out sort of 15 years, knowing what you know about what's happening in the world and sovereign capability, where do you think this could go? And if there was a message to governments about the 2 or 3 things that need to happen to allow something like this to really scale up, how big do you think you could be? I don't mean in dollar sense, but the sort of market you could be in. And then what are the couple of things that you would need?
Yeah, so I think from a strategy perspective, our goal has always been to be that leading contract manufacturer as well as having our own designs, right? So that would mean raw material comes in the door and then finished product goes out the other end. And that can happen for anyone. That can happen for a very large company, a small company, but the problem it's solving is the duplication of efforts, right? So it happens a lot in new space. Everyone thinks they need to have their own engines, their own, their own structures, their own components. When what we're finding is that the economies of scale allow, companies like ours to take advantage of the cost and then to pass that cost savings on to them so they're more fluid in their design and getting to orbit faster, right? Yeah. If you want to blow it out 10, 15 years, I think it's pretty reasonable for Romar to be a $100 million business. Wow. But it's, it's not without, the skills, right? The skills gap and overcoming that. What we've found to be successful is taking new graduates of engineering and putting them in the more traditional TAFE roles, right? So Agnendra is a mechatronics engineer, but he programs and operates our CNC lathe with the goal that over 2 to 3 years, he'll engineer himself out of that position and move on to the next challenge. So pushing automation hard, but at the same time skilling up that workforce.
Which is that whole point about the interoperability between universities and TAFE, so that because employers like you don't want those vertical streams, they want people who you can sort of say blend the university stuff with the practical stuff and get that into sort of a framework. And then other things that, if you were standing in front of the Prime Minister and he said one thing that would make this get to that $100 million, what would it be?
I don't know. I mean, for us, a lot of the problems we understand very well. It's mostly marketing, business development. Sure. A little bit of it is on the design side and attracting that talent, right? So the skills problem is probably the biggest one at the forefront. After that, there's probably going to be the issue around, real estate investment, location. Like we're in an area that's constantly going up in value, so and we're growing, so it's hard for us to find more and more floor space. Yep. Those are kind of the 2 biggest challenges that I think are probably shared in this neighborhood.
Yeah, I'm sure, and across the sector. Well, Steve, it's an amazing business you've got here. This is like, to me, this is Australia at the frontier. This is kind of like Australia's kind of big advantage, and the world is changing, as you and I were talking about earlier. The old days of a production line and labour being the kind of fundamental determinant of profit or loss. Now it's skill, now it's the automation, now it's the equipment creating better jobs. So can I thank you for your time this morning and wish you well, and obviously we'll be a strong partner with you.
Yeah, wonderful. And we really value our partnership with the WPCA, and we're looking forward to that AMRF getting up and running.